what Spark is good at, what kind of pitfalls you can face when running Spark, how it works under the hood. By the end of this talk, you will have an overview of not only most common use cases, but also an understanding of how it works under the hood and how you can use this knowledge in order to fix common problems and make performance Spark jobs. My name is Marcin. I'm data engineer at TantusData. At TantusData, we do everything data related, so from cluster installations through application architecture and development, training, and supporting teams of data engineer and data analysts. And I have been doing everything, but on daily basis, I act as an architect and a data developer. During this talk, first of all, I will introduce you to what Spark is. Then we will have an overview of a few use cases. Some of them will be on a very high level. Some of them will be a little bit more detailed. So the idea is you get an overview of what you can use Spark, and you understand whether Spark is a tool you would like to consider in your business, in your company. Then we will have a little bit of a deep dive into how Spark actually works, and that should give you an understanding how to solve common problems, how to make performance Spark jobs. And at the end, I'll briefly mention the big picture from the point of view of technology, but also the big picture from the point of view of organization and processes. So let's get started. Spark is general engine for distributed data processing. So you can express your business logic in one of these languages, and Spark will take care of distributing the load, distributing the processing into multiple machines. It has a streaming library, it has machine learning library, but for today's talk, we're just gonna focus on the core of Spark. And let's get started with some use cases I've worked on, I've helped clients with. So let's start with a mobile app company example, and let's just simplify it a bit. So let's imagine you have a mobile app which communicates with backend, which writes and reads data to a database, let's say relational database. And what you would like to do is you would like to improve the application. And how you do that? You do that by storing some extra information about how the users are using the application. So events like the user logging to the application, the user clicking on a button, the user scrolling through the screen. So then an analyst can go to the database and understand, for instance, why a given user did not buy the premium subscription. Maybe he ended up on the premium subscription page because he just clicked by mistake and he immediately went back. Or maybe the flow was too complex for him, so he actually tried, but he never managed to finish it. Or maybe the application has crashed. So these kind of events can be really useful for your analysts, and you could use them also for storing them and using them for dashboarding system. And so far, so good. Your user base grows. You have more analysts. They run more complex queries. They run some machine learning on top of it, and so on. But at some point, your company is doing so well that you have to solve some technical problems. Your database gets overloaded with number of events from the users, and your analysts are running complex queries which basically never finish. So you have to solve that. You have to enable your analysts to actually do their job. And fortunately, this kind of problem is already very well known, and there are very standard solutions for it. So what I would propose now is introducing Hadoop and Spark to your ecosystem. So you store the events to Hadoop distributed file system, and you expose the Spark API to your analysts. So they express the business logic now in Spark API, and Spark takes care of reading the data from Hadoop and parallelizing the execution. So now they can execute the queries again. So you are enabled to go further with the growth. So this is what Spark API looks like. I would like to just emphasize on those keywords like group by, max, average, join, select. If you are familiar with SQL, you already get an idea what this does. And the point is, it's quite easy to express the business logic for anybody who is familiar with any modern programming language or even just with SQL. And if you have such kind of API, it becomes quite easy to express all kind of general use cases, like doing ETL, so loading data from multiple sources, transforming it and writing into one common place. Or calculation of KPIs, so you understand how well you are doing with the revenue and how well you are doing with activation. Or many other general use cases you can think of, from simple A/B tests and maybe doing some anonymization to complex machine learning models. But I would like to focus on something a little bit more concrete and a little bit more complex. So a client of mine was doing network improvement. It was a telco. So a telco network is a set of base stations, and basically customers are traveling around. They get connected from one to another, and they get different performance, different throughput, latency, depends on which base station they are connected to and how loaded it is, how overloaded it is. And what we would like to do is we would like to improve the network. So we would like to choose the base stations to upgrade to make our customers happier, so they are less likely to leave the company. So how do you do that? First of all, what you need to do is you need to analyze the historical probes from the network, so you understand how the network behaved in the past for each customer, and you come up with a score for each customer, so you understand how good was the network for this or that customer. And then you could use this score in order to come up with churn prediction model, so you understand how the customer experience with the network affects the churn probability. Then, if you know the expected performance of the new base station, you could simulate how upgrading given base station will affect the experience of all your customers. And once you have that, you could mix those two. So you could mix the churn prediction model with simulated score, so you understand how upgrading given base station will affect your customer experience, the likelihood of them leaving or staying with the company. So as you can see, just 4 steps. All of them can be extremely complex. So they can be extremely complex from the point of view of computations you have to do, and that Spark will help you by distributing the load. But this is also extremely complex from the point of view of you coming up with the model and understanding the domain and so on, and that's, unfortunately, you have to come up with. But if you think about the money involved here, so the money you can save on not doing unnecessary network upgrade, or the money you can gain by keeping your customers with you, for large telco companies, it might be a huge win, so it's definitely worth investing. It's worth investing in. I would just recommend to start with something simple, some linear model, and iterate while you need that. And now, the question is, why am I even showing you this? This kind of analysis has already been done, and they have been done for quite a long time. But the traditional way was that an analyst pulled the data from some data store to some R server or to his local machine, and he does the analysis there. And then that means he has to limit the amount of data. So either he has to do sampling or aggregation of the data. And if you do that, you might end up with this very well-known blind man and an elephant problem. So a few blind men are touching an elephant, and they get completely different idea about what an elephant is. And something similar might happen to your data. But if you are doing the analysis with Spark or a system like that, you can analyze the whole data set. You can do the analysis faster, so you get a faster feedback loop. Also, you avoid extra data copies, which is quite important from the point of view of data privacy and regulations like GDPR. And it's worth knowing that many of common solutions like analyzing social networks, k-means, all kind of machine learning has been already implemented on Spark, so you don't have to do that from scratch. Last use case I would like to show is analyzing and processing geospatial data. So imagine you want to build a map service, either something like Google Maps, or maybe you are building self-driving cars, so you need to build a map which you control, which you can rely on 100%. And if you are about to do something like this, you are getting data from really many sources. So for instance, these cars going around taking pictures, which you probably will blend with some artificial intelligence in order to figure out the street name and so on. Open source geospatial data repositories you probably want to use. You most likely will have an army of editors who are looking at satellite pictures, and they are drawing them up and they are reacting for customers' bug reports, and maybe for some cases in some countries you maybe don't want to invest yet, so you'll buy some data from vendors. So the point is you get data from really many places, and you would like to merge it together. You would like to apply your logic so you end up with new, better version of your map. And just to give you an example of what kind of operations you will have to introduce every single possible salt value. So you duplicate your user records, and then when you do the join, you join not only by the user ID, but also by the salt. So user ID 1 and salt 1 will go to one task. User ID 1 and salt 2 will go to another task. And user ID 1 and salt 3 will go to another task. So it's super simple technique, and it might sound a little bit artificial to you, but this is kind of problem I can see very often, and it very often helps. So there are tons of other problems you might face, and they are kind of unique, but this happens really often, and it is a nice trick to have in your bag of tricks, let's say. One important tool Spark has I would like to introduce you to is caching. So you have to know that when Spark runs the job, it doesn't really store intermediate results to disk. So that means the data will be materialized once it's needed. And that's a nice optimization. You avoid a lot of writing to disk. But at the same time, that means that if you want to materialize the same or similar data twice, it will be executed twice. So here we calculate the blue, the RDD1, which is blue, and then we reuse it twice, and we store the results to disk twice. So that means the blue operations will be executed twice, and sometimes it's completely fine. Sometimes you don't care because it's cheap, but sometimes you know it's very expensive operation and you keep reusing that. So you would like to avoid that. And that's why Spark introduces caching. So you can explicitly tell Spark to cache the blue RDD, so it will keep that in memory, so it won't have to recalculate it. Just to give you an example of an algorithm where caching becomes helpful. So a PageRank algorithm is an algorithm where we do a join of links and rankings, and we do that multiple times. So we join the current rankings with links, we calculate new rankings, and then we do the join again and again. So we iterate over to update the rankings, and we do that like tens of or hundreds of times. And here, when we don't use caching, we keep reading the links from disk. What we could do instead, we could request Spark to cache the links, so then it's kept in memory of multiple machines, and then Spark will be reading the data from the memory. So whenever you can see a branch in your execution plan, whenever you reuse your data set, that is a candidate for caching. But when you plan for your caching strategy, it is really important to understand how heavy the computation is and how large the data sets are, because you cannot pin an RDD to memory. You cannot say that, oh, this RDD or this data frame is more important for me. It will be just LRU algorithm. So if you are caching two different data sets, it might be that because you are caching the second one, you will lose the previous one. So make sure you understand what you really want to focus on to make smart decisions about caching. There are many other gotchas when we're talking about Spark, and I do not have time for that now, but I would be happy to discuss it later on. And there are many other challenges which are ahead if you are considering using Spark, because that probably means you have some big data volumes, and then there are tons of questions from simple ones like data formats, then how do you version the data, how do you schedule your jobs, how do you monitor it and figure out problems with your data, how do you manage your machine learning models, and so on. And there are tons of tools for that. So this is big data landscape for 2017. There are like tiny logos of tons of systems you could choose, but the problem is lifetime is not enough to go through all of them, so you have to make some smart decision. You have to make sure you limit the number of tools to the minimum. You have to make sure that you reuse the tools you already have. And also, I would really recommend to come up with some common tools all the organization is aware of and that they are familiar with, and also share the common knowledge. So on one hand, it's a good thing to share the common knowledge about common problems, like the salting, for instance. But on the other hand, make sure your developers and your ops are doing as much as possible to not make business or analysts aware of problems like JVM problems or garbage collection and so on. So make sure you organize the tools in the right way and the right level. The last picture I would like to show you today is the hierarchy of needs in the data science. So the top of the triangle is artificial intelligence and deep learning. So very fancy words, various things which are hot nowadays, and everyone wants to do that. But I would like to emphasize on the bottom of this triangle, because if you want to get benefits from your data on daily basis, you have to make sure that the way you deliver data is something you can rely, you can monitor that, you have some anomaly detection, so then you can go for more complex analysis, you can do A/B testing, machine learning, deep learning, stuff like that. So 3 bullet points at the end. Spark can definitely help you when you want to process large data sets. It really helps you if you know how it works. Then you can implement your solution much faster and you can solve your problems much faster. And think about the big picture from day one. So think about bottom of this triangle from day one. So first of all, make sure you have the good data and then do more complex things on top of it. I'll be really happy to answer your questions. I have also posted the slides on my Twitter account, so you can download them. I'm not sure why it's displayed in this way, but they should be correct on my Twitter account. And I will be really happy to answer your questions. You still have some time. Can you give some? Okay, so like on daily basis, I work with like tens of terabytes. So that depends on the project. It depends on what kind of calculations. But data size is not necessarily the most critical in some cases. So as I mentioned, for the geospatial analysis, for instance, the data size is just few terabytes, and it's not that large, but the operations are super complex in terms of CPU. So it really depends on the project. So it's not always data size which is the issue, but I've been working on like tens of terabytes, just it. Spark versus Flink, which one? What do you want to do? That's the question. From the ground, Spark has been implemented as a batch processing tool. So, and then on top of that, it was introduced the ability to do semi-streaming, so doing micro batches and simulating streaming. And then from, I think, 2.2, Spark actually does something which is more closer to proper streaming. So I would say for streaming, they are comparable. For batch, I would still use Spark. Because well, Flink is built mostly for streaming. So then you have to rearrange your architecture that you kind of do streaming, and using streaming to simulate your batch. Do I have an, okay, you can see that. Yes, you do have advantage when you use Spark caching, because it's aware of the partitioning, so it can use the data locality. So let's say it knows that this node contains a given partition and it has to do a join with some data from disk, so it can do it smarter. You're still using the same cluster, and it knows where the data is, so it can benefit from the data locality. I have experience only with Yarn, and that one is the most commonly used and supported by vendors. So, like if we're talking about big clients, they most likely are using Yarn. It works fine nowadays. It's also worth mentioning that from 2.3 there is a support for Kubernetes, which is quite hot. People are talking about it, but I have not really seen that on production yet. Thank you.